I want to talk about how we decide which integration technique we're going to use. And I kind of want to do this with a flow chart, kind of a graphic organizer. I'm not going to do a bunch of integration in this. I'm going to maybe just talk about what these types of functions would look like and kind of my thought process on deciding which technique to use. So the first thing I would look for is this. If it were a simple function that involved only addition and subtraction of a bunch of separate little pieces, for example, this. It's x squared, 7x, 1 over x, sine x, a bunch of just little functions that I have a separate rule for, and I could just easily do each individual piece and keep the addition between them. And what I mean by that is, 1/3 x cubed plus 7 halves x squared plus natural log of x, I guess minus cosine x, put a plus c, something like that, where you just get to do each little piece. If that's what your function is, then you just proceed with integrating each little piece. But if the answer is no, next I look for if I instead had a product of two functions. So two functions multiplied together. I'm trying to integrate f of x times g of x. So not a bunch of pieces added or subtracted, but rather pieces that are multiplied together. The first thing I would look for if it's a product is, will substitution work? And what I look for with substitution is, do I have a part, like you can see this is x squared times the sine of x cubed. If I were to make u x cubed, we call it u substitution, the derivative of that is 3x squared, and I could easily transform, let me make that more obvious, it's an x cubed. I could easily transform, the derivative into x squared with a constant multiplier. And I'm not going to go through the whole process just in the interest of time, but again, if u were x cubed, the derivative of that would be 3x squared, and I could make a perfect match by doing this. And I could integrate, and it would turn my integral into 1/3 the integral of sine u du, which is easily integrated. Now, if substitution doesn't work, and again, that should be the first thing you check. If that doesn't work, you go to integration by parts. And this is where, again, you could say, well, if u is x, the derivative of that is 1. That does not help me get rid of the product. If u was x squared, I would end up with my du being inside my trig function. That can't happen, so you go to integration by parts. And this is a formula that you use, or it's this tabular integration method, but essentially you pick one of your functions to be u and the other to be the derivative of v. I can quickly do that right here. You can see I've just done my tabular integration, and you can look at a different video of mine to kind of see that full process, but that's what I would look for. So for products, first check substitution. If that works, great. If not, go to by parts. What if it's not a product? What if it's a quotient? So my kind of standard way to think about quotients, and again, when we're talking about quotients, we mean integrating a function divided by another function like this. The first thing I want to check, much like products, is would substitution work? And substitution would be a situation where you can see that, making like the denominator your u, and you say, well, my derivative of that is 2x, so I could easily adjust like that and make it a perfect match and use substitution. That's what you're looking for. Could u be the denominator? Most of the time it will be the denominator, and then your derivative will help you get rid of the numerator. That's kind of what to look for. The next thing is, does substitution not work? Then I would look for partial fractions. Partial fractions, usually the denominator can be factored, well, always can be factored, and then you can do the kind of, a over x plus 2 plus b over x plus 4. I'm not going to go through the whole process. I have another video about how to do that, but you would use that method. And again, this is if substitution didn't work. Like here, if you think about multiplying this out, x squared plus 6x plus 8, if that was your u, du would definitely not, we wouldn't be able to do anything with that to offset the 3 in the numerator. So that's partial fractions. Now, if partial fractions doesn't work, and usually the reason would be, well, I can't factor the denominator, then I would look for trigonometric substitution. So you see here, x squared plus 4, you can't use substitution because u would be 2x and there's no x up here. You can't factor this because it would require imaginary numbers, x plus 2i, x minus 2i. So we would go to trigonometric substitution and look for like inverse tangent, inverse sine. Now, one last thing I just want to point out, I'm just going to move this up a little bit. The other thing with quotients to kind of look for, if the answer is no, is can I do division? Okay, and this is a kind of a rare thing, and there's 2 different types to look for here. One of those is the integral is something like this, where the top is the more heavy part. It's got more terms, and the bottom is like a single term. And you could say, well, this thing just reduces to 4 plus x, if you just kind of divided each thing, 4x divided by x and x squared divided by x, and then you could just integrate that. Oftentimes, simplifying that just goes to power rule. So look for that. If the denominator is super easy, like a single term, can you just separate out the numerator over that kind of common denominator? The other thing to look for is potentially something like x squared over, x squared minus 9. And here, it's tempting to think you can go straight to partial fractions because you can factor. The problem is we have to do a pre-polynomial division on this because we have the same power on the top and bottom. And really the idea behind being able to do partial fractions is we can factor this out in a way that we can use kind of a modified substitution on these factors. Well, that's not going to work down here because there's no way x plus 3 and x minus 3 in this denominator are ever going to be able to be modified in a way to get x squared in the numerator. So you might have to use division, like polynomial division, which again I have a video about. You can go watch that, but you also maybe could have a simpler division. This, to be honest, is the most forgotten rule. Like, this is the thing that people most often miss. So just be aware of it. Now, real quick, if you are a Calc AB student, you are only responsible for these kind of like substitutions and maybe like this kind of simple division, okay? If you're a BC student, then you're responsible for all of them. So kind of study that, that flow chart. That's kind of the way I would be thinking about these things. Is is it a simple thing? If it's a product, check substitution. If that doesn't work, do by parts. If it's a quotient, you had a lot of things to check. Substitution first, and then maybe partial fractions, trig substitution. If this video helped you, please like and subscribe for more math help.